Now that is in the fresh stage. Now in hardened stage, what happens? Entrained air for freeze and thaw durability. When you are working, suppose in Himalayas, in Kashmir or that area, where your temperature goes down minus level, and you are aware that once the concrete temperature below minus 10, concrete will never hydrate. That is the datum temperature normally we call. When you talk about maturity of the concrete, we always say what is the datum temperature is minus 10 degree. So below that degree, concrete will not start hydrating. So once we get freeze, and then during daytime it heats. So the whole cycle called freeze and thaw. So whatever water is there in the concrete, once the concrete goes in the freezing stage, this become ice. Now ice has got more volume than water. Now if that support is giving more volume, it gives some stresses to the concrete. If you distribute it throughout the body, so give some stresses when concrete is in the hardening stage, not in the fully hardened. It is only set. Because when you are placing concrete such a temperature, we have to heat the everything, including water and aggregate. We have to heat, make the concrete around 10 degree, and then only is allowed to place. Then it will harden. But then it is exposed to that freezing and thawing. These all phenomena will take. Once the temperature is up, the ice become a water. So the stress is releasing. Again cycle will come, again stress will. So with that process, concrete will disintegrate. So you lost their durability. You may find there is a lot of cracks in the concrete. To take care of this phenomena, we are adding air into the concrete. So if you refer all literature other than tropical countries, cold countries like America is there or London, wherever Europe, where the temperature is goes in, they always use air into the concrete, introduce around 6 to 8% air, which can take the volume of extra volume of ice which is created, and it is well distributed throughout the body of the concrete. So freezing thaw effect is minimized. So this is only concept you can just remember, because our country only in the Himalayas you get this condition. Otherwise, all other section of country we don't go with the freezing and thaw durability. Increase the early strength. That what already we have discussed. You can have early strength at even 24 hours, even 8 hours, 10 hours, even 2 hours also. So that is possible. Increase ultimate potential strength, because whatever concrete today we are using, we rarely use 100% OPC, ordinary Portland. We are using a lot of other supplementary cementitious material, combination of that. So once you use those materials, the hydration process starts even after 28 days. And generally also, concrete doesn't stop gaining strength year to year. So we have studied up to 10 years even, it goes on increasing the strength. But the gaining percentage is low. Now, with this admixture, ultimate potential strength also we get increasing. So nowadays also we have for foundations or footings rather. Earlier everybody is talking about 28 days strength. Today we are specifying 90 days strength, because the total load on the footing will come after say 1 year, because building doesn't finish within 28 days. So we can take that advantage and design your concrete accordingly. decrease the concrete permeability, which is indirectly connected to your durability. When you talked about hardened properties, we'll discuss in detail. Reduce potential of corrosion of reinforcing steel, because concrete become impermeable, so pollutant will not enter, it will not attack on the reinforcement, and will have better life of the structure. We can have a increase the life of the structure. We already discussed about reducing heat of hydration. Now, once you reduce the drying shrinkage. Drying shrinkage, what is happening in the same unit volume, your water evaporates and goes away. Now, once it goes away, concrete shrinks, because concrete has got typical property that cement is shrinking. Now, your aggregate is not allowing to shrink, because they are rigid in nature compared to the paste. So paste should be minimized in concrete to reduce the drying shrinkage, and strength can be increased to reduce the water content. So you can use optimum water content with optimum paste, then shrinkage will be less. More cement paste, more shrinkage. More water, more shrinkage. Generally, civil engineers, in our experience, when you go to the site, anything goes wrong on the concrete. Suppose there is a low strength, some strength has an issue, people are go on adding the cement. So more cement is very bad to the concrete. More water also bad to the concrete. So always you use a word to get a properties of the concrete, use optimum amount of cementitious system. Yes, and optimum amount of water. That one has to remember. Reduce the expansion produced by alkali silica reaction. That is also alkali silica reacted admixture today is available in the market. It was not earlier, maybe 20 years back, it was not there. But today those admixtures are available, which also can take care of your alkalis reactive silica in the aggregate. That is also possible. Increase the concrete resistance to the environment. In the same durability. Basically, durability can be increased. Once your water is reduced, your porosity is reduced, concrete become impermeable. Once concrete become impermeable, it's very difficult to enter the pollutant in that, and then it can get better concrete, better life of the structure, and it gives a better performance of that particular structure for the design. Now, whatever infra project we are designing, like you see the metro or you see the MTHL, that Mumbai Trans Harbour project, they are designed for more than 100 years life. So today, we can design a concrete which can last for more than 100 plus years. Now, other than this, we have specialty admixtures also for this specific purpose, specific application. Corrosion inhibitors are there. Though certain difficulties to get a very impermeable concrete during a normal construction practices, then we can use some corrosion inhibitors which can be delayed the corrosion process. So there is a passive layer created on the reinforcement which should not allow to corrode. So those are available today in the market. So we can take care of your structures and design your life more life. Then we have hydration controlled admixtures, as we have discussed, that is super retardants. These are pure retardants. Earlier we were talking about super plasticizer. Now there is a pure retardants. If I add this, concrete will not set. Means you can add such a way that I can control my hydration process, control my setting time. Alkali reaction protection, as we have discussed. Gas forming of foaming agents, because lightweight concrete we are doing, where you don't need a very high strength. And if there is no structural requirement, I can use as a lightweight concrete. The density is equal to 1 or less than 1. So that time the gas forming or foaming agent possible. Dam proof waterproofing admixtures are available. Or integral waterproofing can add into the concrete and you will get watertight concrete possible. Sinkage we have discussed. Coloring of the admixture. We have all decorative concrete, architectural concrete. We can use colors as an admixture because those percentages vary 2 to 3%, 4%, sometimes 0.5%. So you get beautiful color concrete. So that is also possible only with the admixtures. So you can make concrete with white cement and get whatever color you want. But those colors should be stable in UV. So that one has to check again. Then viscosity modifying again. Because concrete is become very, very thin and there's no viscosity, I mean there's no cohesion. A lot of segregation is there, bleeding is there. Now truck has come to the site and it has got huge segregation and you are hurried to use it. I can use VMA, viscosity modifying agents. So once you add this, you will find concrete is become very, very cohesive. Most of the self-compacting concrete we are designed using viscosity modifying agent where we know doesn't need any external energy to vibrate or consolidate. So that is possible. Viscosity modifying agent. Then we have synthetic fibers to enhance various properties in the concrete. You have PP fiber, polypropylene fiber, we have steel fiber, we have glass fibers, and we have natural fibers, coconut tree fibers or banana tree leaf. So those are all natural fibers. If you see your ancient structures, a lot of fibers they see they are in naturally available fibers they are used in the mortars. At that time RCC was not there, but whatever plaster they did, we found that a lot of natural fibers are available in this. Today we have got synthetic fiber also. You can take the advantage of this with the different application. Depending on application demands, we can use those fibers. Now, all these admixtures, how to dosing is a very big issue. So most of the batching plant, we have auto system to dose the admixture into the concrete. So there is a measuring jar we can do by the volume or you can take by weight also. So there is a pump, you can pump as per your batching system and desired quantity of admixture will go into the batch, each batch of concrete on the mixer. Now here one thing you have to remember as a civil engineer, all these admixtures are working on wet cement or wet cementitious system. So they are not advisable to use on dry cement or dry cementitious system. They should not use also along with water. You don't mix it with water and add into the concrete. No, that is not a correct practice. The correct practice is you add about 80% water, let your concrete become wet, all your cement particles should be coated with water, and then you add this admixture, which will give better performance as well as your consumption levels also will be optimum. If you add along with water, suppose you mixing, because most of the batching plant you see there, because this batching plant designed by the mechanical engineers and they doesn't know the concrete. if they sit with the concrete, see the concrete technology, and then design a batching plant, it will give better performance. Now, whatever admixture is there, suppose 180 liters water there, 10 liters of admixture, I'll mix it. Basic concept is it should be distributed everywhere. That's correct. But once you add along with water to the dry cement and dry aggregate everything, most of the admixture absorbed by the aggregates. Because volume is more, around 70%. Now, if it is suppose crushed stone sand, huge water absorption is there. So most of the admixture will absorb only by the aggregate along with water, and that is not available for your plasticity. So this important point you must remember. And if you see the literature also, this admixture manufacturer give the literature, don't add admixture on dry cement in liquid form when we are talking about liquid form. So add only on wet paste, will give better effect, better performance, and lower consumption of admixture. Now, in particular concrete, we have one type of admixture where there is a combination of admixtures also. So, in batching plant are capable of handling 1, 2, 3, or 4 admixture at a time. It's possible. Suppose I set retarder, I can add separately. That's only super plasticizer I can separately, or I can add in the combination also. Again, I want corrosion inhibitor, I can add. So those things one has to see whenever recommending in the plant, and plant is also having a sequence of mixing. As I discussed, sequence of mixing is very, very important in concrete to get better strength with effective and optimum admixture content and cementitious system. Otherwise, you will end up with very high amount of cement system and admixture also for the same performance. So mixing, you must note down, mixing is very, very important in concrete for particular admixtures. Secondly, redosing. Suppose you have applied the concrete and once it is reached at site, you will find you have lost the slump. Then we can do the redosing. But whenever you are doing redosing, you must consult with the QC engineer of that particular RMC. Find out what is the admixture they are used and what is the maximum recommended by their manufacturer. Within that window only we can use that redosing. Otherwise, not possible. It's not allowed. So that one has to see very carefully. Redosing, and that should be agreement between supplier and the RMC people. How to do the redosing, what is the system, there is the SOP will be there. You have to follow that with the proper technical backup. Your truck drivers are not allowed to use any admixture into the concrete transit mixer because they are not qualified. In India, whatever people, drivers who are traveling in the or they are transporting these vehicles, the transit mixers, they are not qualified for concrete. If you see NRMC, even in US or UK, the drivers has a qualification of basic concrete. They have to teach how water is affecting on concrete, what will happen when the concrete has added admixture. Those minimum training is given to the driver also, and their cleaner is not there. In our country, we have cleaner also. Their only driver is there, and driver is only qualified for adding admixture into the transit mixer. But our country drivers are not trained for basic concrete. So they issue a certificate once he goes into 1 week training or 2 week training only in the concrete to understand what product they are transporting. Now, here people are normal tanker water they are carrying, concrete also they are carrying, they are also oil also. The drivers may change. There is no specification for the particular driver. What is the qualification of the driver who is carrying concrete? 6 cubic, 12 cubic meter concrete they are carrying. He doesn't know. So he is worried about his TM. So he can add only water also. Then what happens to the concrete, you know better. So that one has to take care. Or at least whenever you are deputed at the RMC plant, you see that the drivers are trained for minimum concrete, basic concrete requirement at least. Effect of water, effect of admixture, those basic can be trained. There also in the NRMCA US, they also driver only take the slump and show to the client. So they are trained to take slump also, show the client is accepted, they will, which is not in the case of our country at till now. We try to do this lot of things, but it's very difficult because most of the transmixer operator are outsourced. They are not own companies driver. So they are outsourced, they can have multiple jobs. So this is also one has to put note about this, how it will possible. Sorry. So and there is an incremental dosage also. What we have to do is we'll have to reduce the, we have to design such a way. Suppose I have got huge traveling, suppose there is a traffic jams are there. So what I will do at site is at batching plant, I'll add only retarder where concrete will not set, not harden, hydration process can be. Once it is reached at the site, I can add super plasticizer to regain the workability. So that is called incremental dosage, and that is possible. Very effectively it is possible. People are using it, but with the proper understanding, technical understanding. So that is also possible. Now this is how concrete is effective. See here. Now without reducing the water content, only using your admixture, I can have more flow. That is the uniqueness of your super plasticizer or water reducer. See, concrete is become very flowable without affecting the strength of concrete and other properties. See, this is a pumpable concrete. This is how it is very cohesive mix and very easy to pump. There is no segregation, slump is there and very easy to find this concrete. So when you are using admixture, this is taken on the site. Now this is in your crane bucket. And you see the concrete here, how it flows. See the concrete. See. It's very cohesive mix and very easy to place by even crane. So in classification, we have normal water reducer where your slump is water can be reduced 5 to 10% from the control water. When you are saying the water reduction from the control, suppose I got 50 mm slump with X water content. So keeping same slump, I can reduce the water content and take the advantage of reducing the cement or normal water reducing agent. Then we have got mid-range water reducing agents, water reducer around 10 to 15% level. But today, whatever you are using, all are super plasticizer in the range of 15 to 30% water reduction level. A huge amount of water reduction is possible with this type of admixtures today. Because today, the way we are working with concrete and using those crust stone sand having a lot of fines, so that created a lot of water demand. Now that water demand can be reduced with this particular admixtures. So we have sulfonated nylon formaldehyde. Then we have sulfur and naphthalene formaldehyde is called commonly SNF. This is SMF. But generally we go with sulfonated naphthalene formaldehyde is a popular admixtures. And suppose we have lower content of water, we can go with lignosulfonic acids. But today we'll see most of the admixture we'll see in the country or even in Mumbai, Thane, where you are using is your polycarboxylate ether with set and strength enhancing ingredient. That is high PC, mid PC, high in the PC is the polycarboxylate ether. Mid PC means there's a concentration is different. This is maybe 35-40%, maybe 15-20%, here maybe less than 10%. So when you are working for mid low strength concrete, you can use this. Mid strength concrete, say may up to M35 to M50, we can use this. M60 above, I can use this concrete, where I can have a flowable concrete. You can see the effect. SNF admixture, you see here. Now same water cement ratio, this is only cement paste. I use PC based admixture, polycarboxylate ether. You see how it is flowing. This is the effect of admixtures. You're surprised to see concrete has become very easy flowable concrete. Only adding this admixtures. This is a very, very, very effective product in concrete.